In this section, we're going to take a look at infinite limits and limits at infinity here to talk about some other types of limits that we haven't really seen yet. Some of them we haven't seen, and others we can give a little bit more detail about here. So for this first example, I'm going to look at the tables here to determine each limit. So here in this first one, I want the limit as x approaches 3 of f of x. And notice here that these numbers are getting closer and closer and closer to 3. Maybe we don't know the value of the function, or perhaps it's undefined. And then on the other side as well, they're getting closer and closer and closer to 3. So the one thing that you'll want to check here, we know that this is referring to a two-sided limit. The two-sided limit only exists if the left and the right-hand limits are equal. So let's start by looking at the left-hand limit, so the limit as x approaches 3 from the left-hand side of f of x. So here now I'm looking at the left-hand side, so these are values which are all less than 3. And I want to check the y values. What are the y values getting closer and closer to? So here I've got negative 3.7, negative 3.94, negative 3.9982. To me, those look like they're getting closer and closer to negative 4. And perhaps if you had the function, you could even get a little bit closer if you wanted to verify. But generally, the pattern, if there is one, should be fairly obvious. For the other side, let's do that in red here. The limit as x approaches 3 from the right-hand side of our function f of x. So notice that all of these x values, those are all greater than 0. Those are all on the right-hand side of 3. So here I want to pay attention to my y values again. What is happening to my y values? Here I've got negative 4.2, negative 4.05, negative 4.0002. Looks like these values are getting closer and closer to negative 4. So I have the left-hand limit is negative 4, the right-hand limit is negative 4, so that means that the two-sided limit then must be negative 4. So that part is, it's a new way to look at limits, but it is kind of a lot of older ideas from the last section that we were talking about. Similarly here, if I wanted to look at negative 6 here, so the limit as x approaches negative 6 of g of x. So let's start again. Let's look at the left-hand limit as x approaches negative 6 from the left-hand side of g of x. So here I'm talking about numbers that are less than negative 6. Be careful with the negative signs here. So what's happening to our y values here? Positive 5.1. 5.03, 5.0004. Looks like my y values on this side are approaching a positive 5. But then I need to check the other side as well. So let's look at the right-hand limit as x approaches negative 6 from the right-hand side of g of x. Here, these are the values that are greater than negative 6. Again, be careful of that negative sign. It's really, really easy to make a mistake when you're thinking about numbers which are greater than or less than when we're dealing with negatives. But I want to pay attention, okay, the y values that correspond to each of those values here. 7.2, 7.1, 7.0005. It looks like this right-hand limit is approaching positive 7. So the left-hand limit is approaching 5, the right-hand limit approaches positive 7. So the two-sided limit then, well, this limit just simply does not exist or is undefined then, because the left-hand limit is not equal to the right-hand limit. 5 is a different number than 7. So again, this is kind of just reinforcing an idea that we talked about in that last section. Part C, here's where we're going to see something new happen here. So part C, I want to look at the limit as x approaches negative 1. And again, we'll break this down into, let's look at the left-hand limit and the right-hand limit. So here, the left-hand limit, let's pay attention to these y values over here. I've got 100, I've got 1,000, I've got 10,000. So to me, it doesn't look like they're approaching a single finite value, right? They're not getting closer and closer and closer to some number. So if you said, hey, this limit does not exist, I would say, yes, you are technically right. This limit does not exist, but I feel like we can give more information here, right? I want to sort of be able to capture the behavior on this left-hand side of -1. So I want to be able to give a little bit more detail. Well, it looks to me like our numbers or y values here are just getting larger and larger. I have 100, I have 1,000, I have 10,000. They're getting larger and larger and larger. So they're increasing and increasing and increasing. So they may not approach a finite value, but they do perhaps approach positive infinity here. So that kind of captures the behavior on that left-hand side. Those y values are increasing as we get closer to -1. They're increasing, I should say, without bound. They're just getting bigger and bigger and bigger and bigger. For the right-hand side, I want to think about the same things here. So the limit as x approaches -1 from the right-hand side of h of x. Here I have a lot of the same, I think exactly the same y values. I've got 100, 1,000, 10,000. Here again, this limit technically does not exist, but if I wanted to capture the behavior, I'd say, well, it looks like it's approaching positive infinity there. So the left-hand limit approaches positive infinity, the right-hand limit approaches positive infinity. So the two-sided limit then must approach positive infinity. If they agree, right, they both say positive infinity, then the two-sided limit must also be positive infinity according to our theorem. So if you wanted to say that this limit right here, this two-sided limit, this limit, I will admit, yes, it technically does not exist. But from now on, I'm going to say, okay, go and evaluate the limits, use positive infinity and negative infinity when appropriate. So if you say, okay, that limit does not exist, you might get a point or two there, but you will not get full credit because you need to show me and you need to tell me why it does not exist. So when we say this limit is positive infinity, or if I ended up with, say, negative infinity, we're really saying this limit does not exist, and also here's why. So one other thing I want to mention, note that positive and negative infinity are not real numbers. It's really easy to lose track of this fact, and I only mention this fact because I think it's important to remember that because positive and negative infinity are not real numbers, they don't play by the same rules as positive and negative numbers. So what I mean by that is, if you were to take infinity times 0, if it was any other real number, you would tell me it's 0. But because it's infinity, I don't have an answer to that question. That's another indeterminate form, actually. If you wanna reference that from the last section, it's another version of an indeterminate form. I don't know what that looks like. I would need more information because it could be 0, it could be positive infinity, it could be a finite value. So here, just keep that in mind. The other thing I want to talk about in this video here is the definition of a vertical asymptote, which is something that I expect most of us have seen. But if you have a left-hand limit of plus or minus infinity and or I should say a right-hand limit of positive and negative infinity, then the line x equals a is a vertical asymptote of f of x. So you only need one side or the other. You don't necessarily need both. So if you have a function that looks like this, let's say here at 2, the left-hand limit, let's say our left-hand limit is negative infinity. But then the right-hand limit does, maybe approaches a finite value. Here I would still say that x equals 2 is a vertical asymptote here, even though only one side approaches, in this case, negative infinity. If both sides approach positive or negative infinity, that's great. They also don't have to approach the same value. I could have an example where, okay, maybe here at -3, maybe the left-hand side approaches positive infinity and the right-hand side approaches negative infinity. That doesn't mean that x equals -3 is not a vertical asymptote. It's on the contrary. X equals -3 is a vertical asymptote. So In the next video, we're going to take a look at how to find vertical asymptotes and then how to look at the limit of functions nearby close to vertical asymptotes.